This is Pre-Calculus Concept 31b. We're going to look at another set of sum and difference formulas, this time using the sine function. Your two formulas are below. We've got the sine of the sum of alpha plus beta, and then a separate formula that's the sine of the difference of alpha minus beta. Again, we're not expecting you to memorize these formulas, but we do expect that you have them on your toolkit sheet and that you are able to use them as appropriate. Okay, here's an example. Find the exact value. Exact value means we're not going to be using our calculator, but rather our unit circle knowledge. But the angle is 7 pi over 12, which is not an angle that's on your unit circle. There's a big hint here, and that is that 7 pi over 12 can be thought of as a sum. And so we're going to take advantage of that and think about the sine of 7 pi over 12 simply being the sine of a sum of two angles that we're much more familiar with and can use. Okay, so using the formula directly, this sine of a sum is going to be the sine of the first angle times the cosine of the second angle, and then we're going to have a plus sign, and then a cosine of the first angle times the sine of the second. Okay? And now individually I should know each and every one of these. So root 3 over 2 is my first value. I'm going to multiply that by root 2 over 2, which is the cosine of pi over 4. I'm going to take the cosine of pi over 3, which is a half, and I'm going to multiply that by the sine of pi over 4, which is root 2 over 2. All those unit circle values from the previous chapter are important. I get the square root of 6 over 4 plus the square root of 2 over 4, and your final answer is the square root of 6 plus the square root of 2 all over 4. Alright, here's a you try. Find the exact value of the sine of pi over 12. I will give you a hint in this one as well. Pi over 12 can be derived or thought of as a sum or difference of two other angles. Think about that first, and then give us your best answer. Okay, hopefully you came up with the fact that pi over 12 is really pi over 3 minus pi over 4. I have to think a little bit about common denominators to come up with that. And once you have that relationship, you can think of the sine of the given angle as simply the sine of a difference in two other angles. And using your unit circle and filling in values, you should get the final answer down at the bottom. Alright, let's look at one other kind of example that you might see. At the top of this problem is a description, and then you have 4 different questions that all relate to either alpha, beta, or a combination of alpha and beta. Alright, so the given conditions are that the angles alpha and beta are both in quadrant 1, so we don't have to worry about any negative signs or anything like that. And then it says that the sine of alpha is 12 over 13. So just like we talked about last chapter, a lot of times it's going to be really helpful for us to think about a triangle in which this angle exists. And so I'm going to draw a little alpha angle there. And if the sine ratio is 12/13, I know the opposite and the hypotenuse. A quick little Pythagorean allows me to determine that the angle there, the third side there is 5. And let me do my beta in a different color. So I'm going to draw a separate triangle. Don't worry a lot about these being to scale, but if I have a right angle and I think about an angle that's beta, and it says that the sine of beta is 3/5, that gives me these two sides, and my fourth side would be 4. So again, I took the information there and drew a picture for each one of them, and that's going to help us immensely for what comes next. Alright, so question number 1 says, what's the cosine of the alpha angle? Well, I have a picture of the triangle in which the alpha angle exists, and all I have to do is find the cosine of that. My answer is 5/13. There's no real work to do other than the picture here. So obviously that's a big part of your solution, is to show that. Okay, cosine of beta, since I'm talking about the other angle beta, I need to look at that picture and come up with its cosine, and that's going to be 4/5. Alright, for question 3, we're going to have to use one of our formulas for this section. So just as a reminder, if I have a cosine of a sum, it's going to be cosine first, cosine second, minus sine first, sine second. And each of these individually is something that you know, this time not from your unit circle, but from the picture up above. So I've got 5/13 for the cosine of alpha. Cosine beta is going to come from my green picture. I'll actually put that in green just so I'll remember where it came from. And that's going to be 4/5. Okay, and then I have sine of alpha. That's going to be the sine in that picture, which is 12/13. And sine beta, I'll put that in green too, since we're talking about the beta angle, and that's going to be 3/5. Right, so all those values right there come from your picture. Alright, finishing it off, I've got 20 over 65 minus 36 over 65. And I get an answer that's negative 16/65. That might seem a little strange, but it's possible, if you think about it, that I could take two angles, add them together, and they might end up in the second quadrant, and so the cosine of an angle in the second quadrant is negative. Last problem here is the sine of alpha plus beta. I'm going to write the formula here so we have it to look at. Again, this is from your formula toolkit sheet. I have sine alpha, sine beta minus cosine, that's wrong. Oops. Sine alpha cosine beta plus cosine alpha sine beta. Not something you have to memorize, but again, you should be able to get that from your sheet. Sine alpha, 12/13. Cosine beta is 4/5. Cosine alpha is 5/13. And sine of beta is 3/5. And putting all that together, I should get a simple answer. This time it's 48/65 plus 15/65 for a final answer of 63/65. Alright, here's what you try. Your job is to take the information at the top. Right? Probably is going to involve a couple diagrams as part of your answer. Notice the quadrants that these angles are in, that's important. And then you have to find the exact value of the expression below. Alright, hopefully you came up with the two diagrams up here for alpha and beta. Because beta is in quadrant 4, you need to really think about that and how the y-coordinate or the y length there would be negative. Pull out the appropriate formula, plug everything in. Again, the big mistake here is a lot of people forget the minus sign when you get to the sine of b, right? Or sine of beta rather. Since beta is in the fourth quadrant, then the sign should be a negative. So your final answer should have been 63/65.